We're given f of x equals the cube root of sine of the cube root of x, and we're asked to determine the derivative function f prime of x. There's a couple of things to notice here. First, we know to find a derivative, we need to write the radicals using rational exponents, and recall taking the cube root of something is equivalent to raising it to the 1/3 power. And also we have a composite function, and therefore we have to apply the chain rule. Let's first write the given function using rational exponents. We can write f of x as f of x equals the 1/3 power of sine of x to the 1/3. And now again, we do have a composite function. We'll identify the inner function as u. In this case, notice u is equal to sine of x to the power of 1/3. And now we know once we identify u, because we'll be applying the chain rule, we also need to find u prime. To find u prime, though, notice because sine of x to the power of 1/3 is a composite function, we need to apply the chain rule again to determine u prime. So if it's helpful, looking at sine of x to the 1/3, we could identify the inner function as v this time, and think of this as just sine v. The derivative of sine v is equal to cosine v times v prime. This indicates that u prime is equal to, again, cosine v, which is cosine of x to the power of 1/3, and then times v prime, where v prime is a derivative of x to the power of 1/3, which is 1/3 times x to the power of 1/3 minus 1, which is negative 2/3. Let's go ahead and write this using positive exponents. Let's write this as cosine of x to the 1/3 divided by 3 x to the power of positive 2/3. Now that we have u and u prime, we can think of the original function f of x as just u to the 1/3, because again we let the inner function of sine of x to the 1/3 be equal to u. And therefore f prime of x is equal to, in terms of u, applying the power rule with the chain rule, we have 1/3 times u to the power of 1/3 minus 1, which is negative 2/3, and then times u prime. And now we need to write the derivative in terms of x using u and u prime, which is 1/3 times the negative 2/3 power of u, where u is equal to sine of x to the 1/3, and then times u prime, where u prime is cosine of x to the 1/3 divided by 3 x to the 2/3. So now we'll go ahead and multiply and simplify. We'll write this using only positive exponents. So again, we know if we move sine of x to the 1/3 to the denominator, it will change the exponent to positive 2/3. So let's write the final derivative function as f prime of x equals, the numerator would just be cosine of x to the 1/3. In the denominator, we have 3 times x to the power of 2/3, which gives us 9x to the 2/3. And then moving sine of x to the power of 1/3 to the denominator, we have the 2/3 power of sine of x to the power of 1/3. And this is perfectly fine for the final derivative function using rational exponents, but let's also write this back in radical form. We can also write the derivative function as f prime of x equals, in the numerator we'd have cosine of the cube root of x. In the denominator we have 9, and then notice both x and the sine function have an exponent of 2/3, where the denominator is the index and the numerator is the exponent, which means you can write x to the 2/3 times the 2/3 power of sine of x to the 1/3 as the cube root of the square of x sine of the cube root of x. Notice the exponents of 2/3 resulted in the cube root and the radicand being squared. So again, either of these two forms would be correct. I hope you found this helpful.